In every century, there are pioneers who light the way for others, visionaries who turn impossible ideas into realities, whose inventions change our lives, creative thinkers, like Gertrude Elion, who courageously pursue their dreams. To her, nature's secrets are mysteries waiting to be solved, pieces of a puzzle waiting to be made whole. You may not know her name, but Gertrude Elion might have saved your life, or the life of someone you know.
I was fighting, of course, for my life.
On the reading of the kidney biopsy, the doctor really thought that I would need dialysis within a year, or possibly worse, possibly not be alive after a year.
What made my childhood much different than other kids is that I had cancer, I had leukemia.
For more than 50 years, Gertrude Elion used her knowledge of science to help sick people get better, maybe even you.
I don't think anyone ever knows what their life is going to be like, because you plan certain things and then you find that fate plays a hand, and so I would never have expected my life to be what it was.
She was born in Manhattan in 1918, the first child of Robert and Bertha Elion. Her given name is Gertrude, but she quickly became known as Trudy. Robert Elion came from Lithuania. He grew up in Manhattan and became a dentist. Bertha Elion arrived from Russia when she was 14 and sewed clothes in the city's garment district. 5 years later, Bertha married Robert. She stayed at home to care for her family, but she wanted a different life for her daughter. Trudy would graduate from college and have a career. After her brother Herbert was born, the family moved to the Bronx, where she grew up. Even as a child, Elion had a passion for life. She wanted to learn about everything.
I couldn't wait to go to school. I used to drive my parents crazy because they said I couldn't go to school yet, but I already knew how to read, so why was I going to not go to school, you know?
As she grew older, she longed to see the world. She planned imaginary trips, thinking about what she'd see along the way. She could hardly wait to grow up and earn money to travel. Her favorite music was opera. The family had little money, so Elion watched her first opera from the steps in the family circle at the Metropolitan Opera House. She loved the drama and beautiful music and became an opera fan for life. In her teens, she identified heroes, and they were scientists. They seemed like detectives who found clues to solve real-life mysteries.
It was Marie Curie and Louis Pasteur and a book called Microbe Hunters that I think must have changed my life. They seemed to be doing such exciting things and doing so much good. I don't think I ever really thought about what their personal lives were like. You know, it was always their scientific lives that intrigued me.
Always an outstanding student, Elion was promoted 2 years ahead in elementary school. She was only 15 when she graduated from high school. It was 1933, a time of breadlines, hopelessness, and despair. The family lost their savings in the Depression. But Elion could attend Hunter College in Manhattan. It was a school for women that was free to gifted students. Her high marks got her in, but she couldn't decide on a major. Then a tragedy changed her life. Her grandfather developed stomach cancer.
And I actually watched him die in the hospital, going through a lot of pain and thinking that certainly there must be a way to cure this disease. But I didn't see how a doctor could cure cancer unless he had some medicine to do it with. So how would you make a medicine? Well, then you had to be a chemist. And I suddenly thought, why not? Why can't I do it? Just as simple as that. Why not?
In the 1930s, it was socially acceptable for a woman to teach science, But research was considered a man's work. Elion didn't think about social norms. Eager to discover new medicine, she majored in chemistry and graduated with highest honors in 1937. Graduate school was her next step, but Elion couldn't get a scholarship and the family had no money for tuition. Elion looked for a job.
There were virtually no jobs. I mean, who would need a chemist in a depression? And if they needed a chemist, there were PhDs from Harvard who were out of work, who were men. And everybody knew that chemistry was a man's profession. So she was up against it.
I went on interviews, and one time I even thought I had a job because they kept me there for 2 hours. They made me translate German patents on site. And when they were done, they said, well, we've never had a woman in laboratory, and we think you'd be a distracting influence. And that really broke me. I thought, this is over. I can't do this anymore.
But the setbacks didn't seem so harsh after Elion met a tall, handsome math major from City College.
He was sent off to France on a scholarship, and so we really got to know each other through the mail. And by the time he returned from Paris, we were more than interested in one another. And the year that followed was a very wonderful year for me. He got a job down on Wall Street as a statistician, and we were planning to get married, and then suddenly fate took a hand, and he came down with subacute bacterial endocarditis, which is really an infection of the heart valves. 2 years later, he could have been cured, but at that time, he lingered for 6 months and then died.
Elion was inconsolable, but she held on to her dream of discovering new medicine. Over time, the tragic loss would strengthen her resolve to help others. To earn money, she taught school. To gain experience, she worked for a chemist without pay. She earned her master's degree at New York University. She found work as a food chemist, testing pickles and mayonnaise. But the doors to research were still closed.
I had made this goal for myself. I wasn't convinced that it wasn't possible, even though there were a lot of things in the way. I guess I was just stubborn. I was determined to do it, and I guess it was part of the Admiral Farragut idea of damn the torpedoes, full speed ahead.
By 1944, with so many men away at war, science was forced to open its doors to women. Elion was hired for an exciting position at Johnson & Johnson. 6 months later, the division shut down. Elion's father thought she might find work at the Burroughs Wellcome pharmaceutical company in nearby Tuckahoe, New York. One Saturday morning, she put on her best suit and went for an interview. Dr. George Hitchings was the chemist working that day, and he needed a research assistant.
I had actually been interviewed several times that week by other people in other companies. And the thing that was so different about George was that his mind was set on what he was doing, not on what did I think about some movie star or what did I think about the best scientist who ever lived, but rather, here's my idea, this is what I want to do. It's, it's kind of a crazy idea, but we're going to try it. And I was so fascinated by what he was telling me that I thought, God, if I could only be a part of that, wouldn't it be wonderful?
And although he was looking for a PhD, he was so impressed with this youngster and so impressed with her enthusiasm for learning and her ideas and so on that he hired her.
Most medicine of the day was discovered by trial and error, but the innovative Hitchings had a rational plan in mind. He wanted to stop disease by interfering with the DNA replication of disease-causing organisms and tumor cells.
DNA was still very new, and nobody knew exactly how it was put together. But we did know that if you couldn't make DNA, you couldn't divide, you couldn't grow, you couldn't live. And so what we were setting out to do was to interfere with things we didn't want to have: bacteria, viruses, tumor cells, malaria. And we didn't realize that the DNAs of each of these things was different. But it was these differences that we were banking on, really, so that we could find something that would interfere with the DNA of one type of cell and not another. And if we could do that, then we ought to be able to cure a whole variety of diseases.
Proving Hitchings' theory could take years of basic research with no guarantee of new medicine. Yet he was encouraged by Burroughs Wellcome and its parent company, the London-based Wellcome Foundation. This unusual company was fully owned by a charity called the Wellcome Trust. The man behind the trust was Sir Henry Wellcome, a company co-founder. He created the trust in his will.
Henry Wellcome was a very individual fellow, and he had an idea that he wanted to do good as well as to make medicines. He allowed his scientists to follow their own ideas for making new medicines.
He created the foundation with the emphasis on research as the underpinnings for the pharmaceutical industry. Not just making a product somebody else is making, but looking for new solutions to medical problems.
The Tuckahoe scientists looked for new solutions in the cell nucleus. It's like a factory of bustling activity where new life is created. Chemical compounds constantly come together to form new strands of DNA. All living things, from the lowliest bacteria to a human being, grow in a remarkably similar way. The team concentrated on purines and pyrimidines, two essential building blocks in DNA. Elion researched purines. Using only her intellect and the little that was known at the time, she combined chemicals to create artificial purines she thought might look like the real thing to a cell. If she succeeded, they would be taken in by the cell and stop DNA replication.
As time went on and I began to get involved in the testing of these compounds as well as the synthesis, and began to learn more about the biochemistry, I was given much more freedom to decide which compounds I wanted to make instead of being told which ones to make. I was given the freedom to say, I'd like to send this to so-and-so for testing because I think it might work in something. I became more and more independent. But we always talked about the work. We always discussed the results. We always collaborated in the sense of trying to figure out what do we do next and where do we go with this.
They worked on the top floor of an old factory building made of concrete. The lab was above a manufacturing floor with hot dryers, and there was no air conditioning. In the summer, the floor temperature climbed to 140 degrees. Elion wore thick-soled shoes to protect her feet. But she didn't worry about the heat. She was having too much fun.
It was exciting, sometimes dangerous. Every once in a while, something would blow up. It was a big puzzle. Why did this thing work and not that one? And so your mind was constantly mulling over the results. And everybody couldn't wait to get to work on Monday morning. And we didn't always go home at 5 o'clock. In fact, we used to have to punch a time clock, and so somebody would go out and punch the time cards and come back into the laboratory. Say, here, punch my time card, you know. They don't want to pay us overtime, but we want to work overtime.
Watson and Crick did not come up with their model of DNA until the early 1950s, and yet George and Trudy were inventing drugs in the 1940s and early 50s before the publication of the structure of DNA. And they did it because they were using just bits and pieces of scientific knowledge relating to DNA to deduce, almost in a Sherlock Holmesian type way, things that could interfere with that structure or function. And the fact that they were able to bring this hardcore science to drug invention rather than stumbling across discoveries served as a model for most other academic and pharmaceutical researchers developing drugs since that time.
And people actually, when we started, thought we were really in a little ivory tower, that nobody would ever bother us because that was a field that would never come to anything.
By 1948, the enthusiastic group began to see evidence that Hitchings' theory might be right. Hitchings set up networks with researchers at the Sloan Kettering Cancer Institute and other facilities to test promising compounds against disease. Outside the lab, Elion was doing all the things she'd imagined in her childhood. She traveled to Europe, she had a subscription to the opera, and she was finally going to get her doctorate. Or so she thought.
Well, I had felt all along that I should get a PhD. And so I was going to school at night. And I did this for 2 years and thought I was really making progress. When I was called in by the dean, who said, you know, you can't do a PhD that way. You've got to give up your job and work full-time in school. Well, I had to take one risk or the other. I had to take the risk that I could do it without a PhD, or the risk that I would never get a job like this again. And I chose the job.
During those days, cancer research was in its infancy. Patients with cancer were relegated to the back wards of hospitals. Nobody wanted to take care of those people because they never got well. And that was a very sad state of affairs because not only because it signified there wasn't anything important that you could do for those patients in terms of curing them or extending their life, but it was also a fact that the patients knew that. Now, I give that by way of background because it meant that people who chose to go into that were doing it in an environment where everybody said, why are you doing that? You're wasting your time. You're not going to find a cure for leukemia. You're not going to find a cure for cancer. You're wasting your time.
Childhood leukemia was a lethal disease. People didn't even want to subject the children to any intervention. They wanted them to essentially just be given pain medication, left alone, till they died very rapidly.
Elion was trying to make a medicine for leukemia. By now, she'd made 100 compounds. 2 looked promising, but proved disappointing. Then, in 1951, she made 6-mercaptopurine, and it worked.
The first time that I went to the leukemia clinic at Sloan Kettering and saw the first children who had been treated with 6-mercaptopurine, who were in remission, I can remember then the feeling of, we've really done it. It really works.
They would get back to looking perfectly normal. The blood counts went back to normal. Everything clinically returned to normal, and they went back to school and did things that other kids their age did, but invariably they would relapse and the leukemia would come roaring back. But the power of seeing a child go from death's door to being perfectly healthy was an image that you carried in your mind.
Physicians had never seen so many children go into remission. In 1953, 6-MP became a new medicine. It extended the lives of children with leukemia and opened up an entirely new area in cancer research.
6-MP is the first of new chemicals to be used in man.
Given by mouth in a tablet form.
A chemical swallowed like an aspirin.
It doesn't upset the stomach. In years to come, this work will represent a milestone.
They called 6-MP a designer drug, a new kind of medicine that was invented, not discovered. Elion proved there were differences in cancer cells and normal cells. She proved Hitchings was right. Minute changes in a DNA building block could fool malignant cells. Other scientists began using these new principles to create medicine, and doctors tried new methods of treatment.
The real downfall of the early experiments was that the leukemic cell became resistant to the drug. Now, if you put in 2 drugs or 3 drugs that all work against the leukemic cell, but differently, the ability of that cell to become resistant to all 3 drugs is much less than to become resistant to 1 drug.
And so the concept of combination chemotherapy really derived out of the experience of treating childhood leukemia. And as soon as that was accomplished with childhood leukemia, the same principles were applied to Hodgkin's disease, and now that disease is curable.
We learned that you didn't stop treatment when the patient went into remission, that you had to continue treating for at least 2 years. But it turns out that 2 drugs that are used today for the 2-year maintenance therapy are the first 2 drugs that were ever used for acute leukemia: 6-mercaptopurine and methotrexate.
6-MP was a critical stepping stone in the fight against leukemia. But the impact of this amazing medicine was even more profound.
The biggest change came about with the concept that you could cure cancer.
And on December 10th, 1986, I got called out of a meeting. I was told the blood tests had come in. I had to come over to see Dr. Teresi right away. And he said, "Your son has leukemia." And I felt my forehead turn ice cold. I actually thought my head was going to fall off. But the fact is, the first time we met our doctor, who was the director of the hematology oncology clinic at Children's Memorial Hospital, he said, "We're going to do this. We're going to cure him. We're going to treat this. This is a manageable illness. This isn't the way it was."
On to Queen 4.
I was diagnosed with acute lymphoblastic leukemia on December 10th, 1986. I shortly thereafter went into full remission. I was in chemotherapy for the next 3 years, during the course of which I took a lot of medicine, no radiation. I went off chemotherapy in January 1990.
He took 6-MP from the very beginning. He took it with prednisone, with allopurinol, with L-asparaginase. He took it from the very beginning, and he took it throughout.
I'm physically healthy. I'm mentally healthy. And I could honestly look at myself and say, and have to ask myself, did this really happen?
In 1957, the Tuckahoe lab was buzzing with excitement. Breakthrough medicines to fight leukemia, malaria, and bacterial infection had come out of their research. The Hitchings-Elion collaboration was a tremendous success.
Hitchings and Elion, it was one word, and that's how they were in the scientific community. They came to the meetings together. They were joint authors on presentations and papers. When you went to their laboratories, you met with both of them. They were a blend of ideas as well as personalities.
They both were obviously very, very brilliant scientists, but they had different styles that synergized. George was more philosophical. He was more the abstract idea guy. Trudy was much more, let's reduce it to practice. Let's see if that really works.
They had put together a comprehensive multidisciplinary research team with a PhD in biology and organic chemists and a pharmacologist and a bacteriologist, all of us trained in our disciplines but working on the same problems from different vantage points. And of course, Trudy was in the middle of this all the time.
By now, Elion had published 60 papers. Despite her success, she was concerned about her credibility with other scientists. After all, it was standard practice for serious researchers to hold a doctorate. Hitchings thought peer recognition might substitute for the degree. He nominated her for membership in the prestigious American Society of Biological Chemists.
He wrote a letter which kind of took me by surprise, and it said, "I know she has 3 strikes against her. She doesn't have a PhD, she's a woman, and she works for industry. Nevertheless, I'm going to tell you about her." And when I was elected to that organization that spring, I thought that was the most wonderful thing that had ever happened to me.
Elion wanted a better medicine for leukemia. She created variations of 6-MP, trying to keep the medicine active longer in the body. One compound was azathioprine. It wasn't better for leukemia, but it held the answer to another medical mystery. In 1957, a young hematologist at Tufts University asked for 6-MP to use in his research.
Well, Dr. Damashek and I had the idea that the immune system responds to a foreign antigen by proliferation of lymphocytes. At that time, that idea was new.
Lymphocytes are white blood cells that form the first line of the body's immune defense. They multiply and produce antibodies to destroy foreign intruders, antigens like infection, or bone marrow transplants.
Since we were hematologists, and we had the idea that we were dealing with a system that involved cell proliferation, which is what leukemia involves, we had the idea of using an anti-leukemic drug to see if we could suppress the immune response.
Schwartz learned that 6-MP suppressed the immune system in rabbits and decreased the production of antibodies.
He came to us very excited, got us all excited, said, you have got to look at these compounds to see if they suppress immune response. Okay, that's a good idea, let's do that. And sure enough, we began to see that some of these compounds did inhibit the immune response. You've got to have a spirit of adventure that you don't have to stay on the same path all the time. If somebody shows you another road, by God, you can take it.
In England, a young surgeon was intrigued by this research. Dr. Roy Kahn thought it might be possible to save lives with organ transplants.
There are many, many people, and there were then more, who were dying just because one organ wasn't working correctly. And this seemed to me, I suppose I was interested in cars and the way things work, and what they needed was a new spare part and they'd be fine.
Back in 1954, at the Peter Bent Brigham Hospital in Boston, Dr. Joe Murray had proven it was possible to successfully transplant an organ from one person to another.
This was accomplished in identical twins, one of whom was dying of kidney disease, the other healthy. It was a spectacular success, worldwide attention, and it just re-enthused many groups around the world to study kidney transplantation.
But identical twins have the same genetic structure. When doctors transplanted a kidney from a person who had different genes, the recipient's immune system rejected the new kidney. The transplant movement came to a halt. Now, 5 years later, Kahn was conducting transplant research with dogs. Perhaps this 6-MP could prevent organ rejection. He tried it and had some success.
He came to Boston to do a fellowship, stopped off to see us in Tuckahoe, told us about his work with mercaptopurine, said, "You have anything else I could try when I get up there?"
And I remember Dr. Elion rushing about in the lab saying, try this compound might be worth trying, this might be worth trying. This is similar to the 6-mercaptopurine, this is a bit different. And she gave me a number of compounds to try when I was in Boston.
Kahn worked with Murray at the Harvard Medical School, a world center of transplant research. The Harvard team kept in close contact with Tuckahoe. The goal was to have kidney transplants across the genetic barrier.
And I worked full-time and overtime trying to find out which was the best compound. And the best turned out to be Imuran.
Azathioprine would become a medicine called Imuran. And a dog named Lollipop became a symbol of their success. 6 months after her kidney transplant, Lollipop had a new litter of pups and perfect kidney function with Imuran. By the end of 1961, it was time to try Imuran in patients. All of the research had been done with dogs, so the patients and doctors knew it could take time to find the right dosage for man.
We'd explain this to the family, and they universally grasped at it because it was their only hope. First patient we did was doing beautifully for about 45 days, and then his bone marrow got toxic and he died. We couldn't keep him alive. The next patient, we cut the dose in half, and the same thing happened. And it wasn't until a patient we had done in April of 1962 that we hit the proper dose and the circumstances worked.
We were very much involved with knowing who the patients were, getting samples from those patients, going up to visit the patients, visiting Joe Murray, visiting Roy Kahn. And so it was almost as though the laboratory and the clinic were side by side.
Imuran prevented organ rejection. The breakthrough caused a revolution. Within a year, doctors performed 200 kidney transplants. Lung, liver, and spleen transplants were underway. Heart, bone marrow, and multi-organ transplants would follow.
It was a very exciting time because we had the excitement that the clinician feels when he does something useful for a patient, and knowing that it was something that we started.
The kidney problem that Sharon had was a big surprise to us. We had been married about a year, and we found out that she had a potentially serious, life-threatening kidney disorder that could result in her needing dialysis or her dying. In fact, she did quite well for about 12 to 13 years until slowly and progressively her kidney function began to decline.
I had met some people who had had transplants. One person who was 2 years post-transplant. And at that point I thought, my gosh, 2 years, that's fantastic. If only I could make it 2 years.
Luckily, Sharon has a wonderful family, and she had more than one willing donor in her family. Her brother, being the best match, willingly gave his kidney transplant to Sharon in early January 1982. And in retrospect, she made a very wise decision to take Imuran and prednisone as her two major immunosuppressive medications at the time.
I like to consider myself very healthy and quite normal. I think just looking at me, I don't know that anybody could tell that I had a kidney transplant. And I feel terrific.
Imuran had done something quite different from what we'd expected, but we went ahead with it. And at the same time, we said, well, there must be other ways to improve on mercaptopurine.
This time, Elion used allopurinol to keep 6-MP active longer in the body. Her theory was right, but allopurinol wasn't better for leukemia. It held the answer for treating one of the oldest diseases known to man.
We had a patient who had both chronic leukemia and gout, and we were treating this man as part of our program to study the effect of 6-mercaptopurine together with allopurinol. And this man kept coming back saying, you know, my gout's getting better. And it wasn't just a question that he had pain in his joints from his gout. This man had what's called chronic tophaceous gout, which is a mouthful, but he had these big deposits that looked like rocks. His hands looked deformed because of the gouty deposits in his joints. And he had it in his toes as well as he had these big lumps that looked like pads sitting on his elbows, which were deposits of uric acid. And he said they're going away. These great big deposits of uric acid just melted away the way you would melt butter. And it was quite miraculous.
So here we were in another field that we hadn't really anticipated with a very good treatment for gout.
In 1966, allopurinol became a new medicine called Xyloprim.
Allopurinol has also been used very extensively to help patients getting chemotherapy in the treatment of Hodgkin's disease, for example, as well as other kinds of cancers.
I think what we were doing was trying to get to the bottom of every mystery, if you like, or get to the bottom of why a compound works and why it doesn't work. Well, if we hadn't been curious enough to do that, we would never have gotten into these other fields.
In 1968, Hitchings was promoted to Vice President for Research and Development. He assumed new responsibilities, and was no longer as directly involved in new drug development. Elion was promoted to head a new department of experimental therapy, the forefront of new research. She built a multidisciplinary team of scientists and gave them a common goal.
She very often reminded people that we were in a very serious business, that there were sick and dying people, and we were in the unique position to do something of lasting importance to help people.
The goal was always to find some new medicine, a new cure for something for which there was no cure. It was always that something that was going to benefit mankind in the sense of solving a medical problem.
In 1969, Elion was awarded honorary doctorates from both George Washington and Brown universities. It was 25 years after she joined Burroughs Wellcome. Finally, she could officially be called Dr. Elion.
My mother died quite young of cancer. My father died a few years later of a heart attack. And I must say that when I got my first doctorate, I had wished they were there. To see that it wasn't all a dream, that it really did come true.
With the corporate growth generated by the new Hitchings-Elion medicines, Burroughs Wellcome outgrew the Tuckahoe facility. In 1970, the company moved to a new headquarters in Research Triangle Park, North Carolina. 5 years later, Hitchings retired from active research. His retirement drew a remarkable gathering of their collaborators, oncologists, hematologists, immunologists, transplanters, infectious disease physicians. They knew it was the end of an era.
Most of the research in the pharmaceutical industry is focused on a specific disease. George and Trudy focused on a specific area of biochemistry and were able to come up with therapies for many seemingly unrelated diseases.
Later in this decade, Elion would astound the world with the answer to a new medical problem. Many people say it was her greatest achievement.
We had this sort of booming incidence of this severe disease we call primary genital herpes. You know, I would see one patient a week who would be admitted to the hospital services with this illness, and we had no therapy.
Genital herpes is caused by one member of the herpes family of 5 viruses. Other strains of the virus cause chickenpox, shingles, and more serious illness.
Antivirals weren't a big part of the pharmaceutical industry's research. There was a lot of pessimism about that therapeutic area.
The philosophy was that viruses have to live inside cells of your body. So in order to, quotes, kill a virus, you had to kill the cell.
What a virus can't do is it can't make itself. The cell is a rich soup of all of the building blocks. So the virus gets in, it says to the cell's DNA, you turn yourself off, you make more of me. Then the cell ruptures, liberating the virus. Cell is reinfected, other cells, and this process goes on.
Elion had turned her attention to antiviral research just before the move to North Carolina. Her team had a few promising compounds when Dr. Howard Schaefer joined the company in 1970. Elion encouraged Schaefer to send his compounds for antiviral testing, and they turned out to be active against the herpes virus. The best was called acyclovir.
It almost blew our minds. I think if anything was a eureka, if anything was a, my God, I don't believe this, that was acyclovir.
For decades, scientists had tried to create a magic bullet, a medicine that would selectively eliminate disease without affecting healthy cells. Acyclovir seemed to be a magic bullet.
When we found that the compound was extremely active on the virus and very non-toxic to the cell, we were bewildered, and we had to know why, obviously.
Elion led the team to develop acyclovir. It would take 2 years of research before she was convinced of the results, because what the team found was astounding. An enzyme in the herpes virus itself activated the medicine. Once that happened, acyclovir was taken into the DNA chain and stopped the viral replication.
It is like the virus committing suicide because it really is responsible for that enzyme that activates acyclovir. If it didn't do that, the compound would not be active.
Elion and her team discovered the chink in the viral armor. The research proved it was possible to create a safe antiviral. Acyclovir became a new medicine called Zovirax.
All of a sudden, the STD treatment guidelines now included an effective form of therapy for genital herpes, acyclovir. And like between 1979 and 1984, all this stuff happened.
In the United States alone, Zovirax helped more than 20 million people who had genital herpes and saved the lives of others with more serious illness.
When people are under cancer chemotherapy or have become immunosuppressed, herpes simplex virus can reactivate and cause much more severe disease, even disseminated disease, and get to the lungs and the liver, etc. And then bingo, all of a sudden you get this drug. This drug which for the first time when you infuse it, wow, it makes people better. And it made people dramatically better.
We showed you could have selectivity, and that was the name of the game, selectivity. Not you can destroy a virus, but you can do it without destroying the cell. And once that was shown, everybody went into the antiviral business.
It has created a billions and billions of dollar industry and a billions and billions of dollars research effort because it was that conceptual hurdle that it could be done. And prior to that, it could not be done. And when HIV was discovered as a virus, you immediately saw work on it. And it was really more of a roll up your sleeves, let's get down to it because we should be able to do it, rather than this is impossible.
Elion was still enjoying the tremendous success with acyclovir when she celebrated her 65th birthday. She decided to retire from active research.
At that point in time, she had a few health problems, and everybody thought, well, she shouldn't work so hard. And we knew she was going to stay on as a consultant, and we can go down the hall and talk to her. So it wasn't a sad occasion. It was quite a joyous occasion.
The time had come for me to leave it in the hands of the young people who had grown up with me and to sit there sort of like a proud mother and watch her children develop. And that's what they did. They all have done exceedingly well. And they went ahead with the antiviral program and worked on AIDS and were successful with that. And people often give me credit for that, but my credit was only in training them, not in the actual work on AZT. Now, the following week, I have a flight at 7:30 in the evening, and I'll be back on Monday at 10:44 a.m. Now, on Wednesday evening...
Elion's retirement schedule was even busier than her official working life. Now she helped solve other medical problems.
When she's encountering huge and so far unsolvable problems, like how's the world going to handle a malaria problem? Huge problems that thousands of people haven't figured out yet. Trudy doesn't sit back and say, well, it's impossible. The geopolitical circumstances in many countries are such that you can't do it. Trudy will just sit down and say, well, we've got to come up with safer, more effective anti-malarials that are not as expensive, that don't induce resistance, and can be given in certain ways, and then work with the WHO or the World Bank or what have you to get there.
I think we're all aware that up to 300 million clinical cases of malaria occur each year, with somewhere between 1.5 and 2.5 million deaths, mostly children under 5.
She has been helping out with this program, which tried to develop tools for the poor people in the world living in tropical countries. She led the decision to take one of the Chinese drugs, based on a herb forward as rapidly as possible into clinical testing. The result of that clinical testing showed that the mortality from malaria could be reduced by 2/3. This new drug is being widely used in countries like Thailand, Myanmar, Vietnam, and Kampuchea.
I know she has a very clear idea of what is needed when a problem has to be solved, and she somehow puts her finger on the right persons and the right questions to ask them as to how to get it done. I think that's probably it. I mean she knows probably instinctively how best to get things done, how to get people to stand up, speak up, and shut up, you see.
No longer in the laboratory herself, Elion began mentoring medical students with Dr. Henry Friedman at the Duke University School of Medicine.
What we're really trying to do is two things. One, make scientific advances, certainly, but two, train a generation of medical students that they can really learn to both use the lab and the clinic in sort of a joint career, a twin career, so to speak.
And this is CPT plus cyclo, kind of as a negative control.
Right. You always do your data so beautifully. It's a pleasure. This is a nice dose-response curve.
Right.
I want to open the door for young scientists. I want to open the door for young doctors, and to watch their awakening to the importance of research in their own profession is a very satisfying thing.
I also have several laboratory programs of my own that I discuss with Trudy, who still continues to serve as a sort of mentoring role to me. I've been able to discuss with her the design, the execution, and most excitingly, the results of the clinical trials as we go from lab into clinic, which is really both of our major goals.
I heard something about Dr. Elion and the Nobel Prize, and then it was off the radio again.
I'm listening to the morning news, and they announced that Hitchings and Elion had won the Nobel Prize. And I just about went off the road.
I was in a meeting in St. Louis, and I went downstairs. It was a pediatric oncology group meeting. A lot of people were there, including Don Pinkel, one of the truly early pioneers of leukemia therapy, who used 6-MP in his treatment. And it was as if they had just announced that everybody in that room had won $1 million lottery.
I was getting dressed to go to work, and I got a phone call from a radio reporter who informed me that I had just won the Nobel Prize. And I said, oh, sure. Who put you up to this? This is a kind of practical joke I don't find amusing at 6:30 in the morning. And you go back and tell that person, I am not amused.
They shared the prize with Sir James Black of Great Britain. It was the first time in 30 years the Nobel Prize had been awarded to scientists who worked in industry. Hitchings was 83 years old. Elion was 70. The Nobel Committee said any one of their medicines could have received the prize, but it was awarded for groundbreaking principles that all scientists could use to make a variety of new medicines.
And I haven't met one person yet who hasn't come up and thrown their arms around me and said, well done.
I think the rewards, and I think Dr. Hitchings said it, are in the drugs and in the patients. On the other hand, the feeling that these people have had for the company and for the whole research team of what this award means makes it much more important to me. The ceremony is beautiful. It's, you know, they've been doing it for 90 years and they know how. It's very formal, really, the ceremony itself, because it's all done on the stage of a concert hall.
Gertrude Elion. Dr. Elion has brought a very large entourage to Sweden, including her brother, his children, and many colleagues and friends. The wording on the medicine diploma is from Nobel's will, for those who have conferred the greatest benefit on mankind.
I think the banquet was maybe more exciting than the actual presentation, particularly when I walked down the grand staircase on the King's Arm. Now that was something really special. Of course, I was always thinking I might trip and bring the king down with me, but we made it to the bottom with no accident. It was all very much afterwards, did it really happen? Was it all a dream? And my little grandniece said, it was a fairy tale. It had a king and a queen. And I think that describes it. It was like a fairy tale. You were there, but you weren't sure it was all happening to you. It was like observing someone else going through all of this.
I picked up the New York Times and I became ecstatic because by the time November '88 had come around, I had been crushing 6-MP and feeding it to my wonderful son Chaim for the past 2 years, and there I was face to face with a woman who had been inspired to produce it, invent it, discover it, whatever it was.
And 6-mercaptopurine, it saved my life. You know, it was one of the drugs that, you know, that has kept me here.
I think it's fabulous that she was awarded a Nobel Prize because at this point, people know her name. I would never have known that there was actually a person behind the medication that I take. Because of the work that she did with Imuran and because of the kidney that my brother gave me, I'm alive today.
It is a shock when you, 48 hours before, you are feeling quite okay, you are normally working, living a completely normal life, and suddenly you are diagnosed with a leukemia. I learned about the work of Dr. Elion through my friends, through my doctor friends in Seattle and also in Barcelona. Some of the therapies that she discovered, I've been treated with. I mean, when the doctor said to you, well, you are under remission, you have green light to live a complete normal life, the feeling you have is gratitude. Gratitude to the medical and scientific community, to your friends, to your family, to the world in general.
I met Jose Carreras in Barcelona on the occasion of a transplantation meeting. He had benefited from a bone marrow transplant, which had cured his leukemia. Most of the patients that I have helped have not been people that I've seen. They've written to me, and I treasure those letters. I keep every one of them, because that puts it on a very personal relationship for me. And every time that I talk at a meeting or at a seminar, somebody always comes up and says, my child had leukemia, is now cured, or I have a transplant. I mean, it seems to me that it's so widespread that it really affects me to know how many people have really been impacted.
Our next guest began her pioneering laboratory career as a food analyst for the Quaker-Made Company, measuring the acidity of pickles and checking berries for mold. She went on to win a Nobel Prize, Gertrude B. Elion.
Today, the woman who wasn't certain she could succeed without a PhD holds doctorates from 26 universities in the United States and Europe. Each passing year brings more recognition for her work.
She's just one of 10 women who have ever won a Nobel Prize, and she is the first woman ever introduced into the Inventors Hall of Fame.
She is what's called a foreign member of the Royal Society, which is a very small select group of people, and having the Nobel Prize by no means guarantees that you'll get it. I think the significance, particularly of a foreign member, because I think it's much more difficult for a foreign member to become part of the Royal Society, is that the work is not only important and spectacular, but also that it is recognized over a period of time, that is really, it has worth that lasts.
I think one thing the Nobel Prize does do for you is people listen to you more.
Well, now you're
I don't
talking.
know any more than I knew before, but I must say people do listen.
But recognition wasn't the greatest change in her life.
You should have a goal toward which you can work. You know, in The Man from La Mancha, they call it the impossible dream. But there's nothing wrong with an impossible dream.
What it has done is given me the responsibility of imparting to young people, and particularly to women, the feeling of how important research is and how exciting it can be. It's a particular responsibility for me because there have been so few women Nobelists, but it's kind of an awesome one.
Elion continued traveling the world, lecturing to people of all ages. One unique meeting brought together Nobel laureates and a new generation of researchers and physicians.
What I simply want to share with you is a feeling of optimism that we now have, that we can do something more for AIDS patients than we've been able to do in the past by understanding something about the mechanism by which these drugs work, but also understanding that the only way we're going to get away from resistance is going to be with combination chemotherapy.
Lindau has become a tradition. It's very important for the students to have this opportunity to meet with the prize winners and to learn from them. And I think it is also important from a Nobel perspective because it gives a continuum to the Nobel activities.
Lindau's the only place I know where Nobel laureates can really get together on an informal basis and meet people whose names they've known for years but whom they would never meet ordinarily. I think it's very good for the students to meet the Nobel laureates on an informal basis because most of them look upon us as a little strange and not quite human. And I think they need to see the human character of the Nobel laureates, to talk to them on an even footing, to feel eventually that there's no reason I can't be a Nobel laureate. And that's what it's all about.
Elion never married, but she always found time for family, her brother, his children, and their children. And she continued to find happiness in the same activities she loved in her childhood: learning, traveling, and going to the opera, where she now had a front row balcony seat.
I've always thought of myself as an adventurer because I'm always looking for new things. I'm always traveling to new places. I don't hesitate even now to go to Antarctica when I probably should have done it 30 years ago. And whole life is an adventure.
In 1995, the Wellcome Trust divested its interest in the Wellcome Foundation, which included the Burroughs Wellcome Company. The foundation was sold to Glaxo plc and became part of one of the largest pharmaceutical companies in the world.
The Board of Directors of Glaxo Wellcome hereby acknowledges the significant contributions made by Dr. Gertrude Elion and Dr. George H. Hitchings, and in recognition thereof, the Burroughs Wellcome main building be and hereby is renamed the Elion Hitchings Building.
I'm really quite overwhelmed, not only by the dedication of this building to George and myself, but by some of the laudatory things that have been said here today.
Her life has been dedicated to finding medicines for the benefit of humankind and to teach and lead other people to pass on the baton so that others also can have that same goal.
Trudy's legacy is as a woman without a PhD who succeeded against all the odds. A woman before her time, and she succeeded.
Trudy has really revolutionized virtually every aspect of medicine that an oncologist would practice in. Better drugs, better ways to give other drugs more safely. She's just changed the entire field.
I think she was a role model for me in the sense of showing how you could link basic science with clinical research. And I think Dr. Elion did that with many other scientists, those of us at Duke as well as at Sloan Kettering and many other places at Harvard and elsewhere.
There's no question that Imuran was the key drug to initiate worldwide organ transplantation and also bone marrow transplantation, because it was the money that you had in the bank to start the whole process.
From my point of view, her legacy is the entire field of antiviral chemotherapy. I mean, it was, just an orphan out there. Now it's a mainstream field in which anti-herpes drugs, anti-HIV drugs, anti-hepatitis B drugs, now anti-influenza drugs are just burgeoning. And acyclovir fostered that entire field. She's given us lots of legacies, and that's why she's a Nobel Prize winner.
There's a certain amount of luck, of course, you need it, but the point is that having got the luck, you have to have the intelligence to select and to put forward the things which are likely to be most useful. And that requires a good deal of intuition and genius.
Oh, I wish my mother had lived to see it all. I think she had so much faith in me at a time when nobody else seemed to, that it would have been a nice reward for her to see that I really did finally accomplish something. But I think she would have been happy to know that the kinds of work that I did and the kinds of diseases that we worked with was something important. It was something she herself would have loved to have done, in the sense that she wanted a career. She never had the education or the opportunity to have one, but she desperately wanted me to have a career, and I think she would have been happy.